All right, so in this video, we're going to do some actual examples with with real functions on how to use this definition of a derivative that we've worked so hard to derive and get comfortable with and get familiar with. We're going to actually use it now to compute actual derivatives, which is the point of the next couple weeks at least of the course. So just a very quick reminder, this what you see on the screen there, this formula for the derivative right here is the definition of the derivative. And in particular, what you see on the right here, this, if you remember, on, oh, actually I can flash back to it. At the end of the last video, well, this looks kind of messy, but at the end of the last video, I gave you these steps, 1, 2, 3, 4 there. As sort of a guide, I guess, to help you actually do this now, right? So we've spent so much time getting here. So okay, what do we actually want to do now? Is actually use this thing to compute the derivative. That's the last line of the last step. So so just a quick reminder, I have the formula, okay, and what should I do in order to use it? Well, we're going to have some specific function in mind, and I'll do, I think, 3 examples for you. And what is it that we're going to have to do? Well, I need to do this, right? I need to do that. Well, what does do that mean? Well, all right, what is that? Well, it's a formula, I guess. So what do we know about formulas just in general? The idea should be that I'm filling in the particulars of the formula, and then I'm going to do something with it, and hopefully that gets me an answer. That's sort of just generally how a formula works. So what is the first step I should probably do is to just take some time to fill in, well, what are these pieces? Okay, what's that piece and what's that piece in particular? H, I don't really have a whole lot to say about that. I'm just going to sort of leave that alone for now. Okay, so I'll fill in those 2 pieces, which might be sort of a mess of stuff. So what the crucial step is really then step 2, which is to use algebra to simplify the top of the fraction. And after you've sort of simplified, what you should be able to do is factor out an h. So it should always work out this way. If you find yourself unable to legally factor out an h, you've probably done something wrong in step 1, so go back and maybe start over. But you should be able to factor out an h legally, and again, factoring just meaning every term has an h, at least one h. There might be an h squared and things like that, and that's fine, but everybody has at least one h to factor out. So if you factor out an h, you end up with something that's going to look like basically like this. And the key step, or the key observation, is that if you get something that looks like that, you have an h times some stuff on the top, and on the bottom you just have h. Well, if you have something on the top and the bottom, and everything is multiplied, which it would be in this case, you can cancel out the h's, and that's just a fancy 1, right? Like 5 over 5 is really just 1. So h over h is just 1, so they cancel, and you're left with just stuff, whatever that is. That's step 3. And then but the very good news is that by the time you get to finish step 3, you'll have canceled your h's. Now there might still be some h's floating around in the stuff, but you'll have done the very key step, which is that, remember, our last step, what was magical about this whole process that we've done is that at the end, we said that all of this stuff we did, all of these guesses and all this computation, everything, all of that was so that we could get an idea of what the derivative was. And our guess, or our strategy, only really pans out or works if I choose h's that are very, very, very small. In fact, and this is where you have to use your imagination a little bit, I want them so small that I might as well say they're 0. In other words, I might as well say by the end of this process, I'd like h to actually be equal to 0. In reality, h is just an infinitely small number, but okay, and 0 is the smallest number we have. So let's say, all right, so I'd like to plug in h equals 0. Well, I can't do that at the beginning of the problem because it would create a divide by 0. But once I've done step 2 and step 3, I should say, once I've done step 3, I have canceled out the h that's on the bottom, which means all I'm left with is stuff, which is no longer a fraction, or no longer, has an h in the bottom. So finally, at last, I'm able to actually do the magic sort of moment, have the magical moment where I plug in h equals 0. And at the last step, that's what I'm going to do. And what you'll see is that if you have h's in this stuff, those will all cancel out. When you plug in h equals 0, you're going to get probably some zeros. That's fine. And then whatever survives, that is the answer. That is the derivative. Okay? So I'm going to do a couple examples, as I said. Whoops. And hopefully this will drive home at least the method. I know it's probably still a little foggy about what all this stuff is, and okay, if you're still unclear as to why some of this stuff, where some of this stuff came from, I'd really say just rewatch, especially the recap video, the last one, but maybe the whole series, just to get a better sense of where did that come from? Why did we put that there? And hopefully it'll become clearer. All right, so let's proceed and do an easy one first, of course. So let's say I want to compute. So what are all of these questions? These questions would all say, compute the derivative, or compute, I'll say, f prime, which is the derivative. Using this formula right here, right? This is our guy. So let's take an easy one first. Maybe something like 2x plus 3. Now, I claim that's an easy one because hopefully, I don't want to give away, spoiler alert, but, this is one if I'm trying to compute the derivative. Remember, derivative is slope. Well, I don't think we actually need this heavy machinery to know what the slope of this graph is, because hopefully you recognize that that's just a line, right? Y is the same thing as f of x. Y equals mx plus b, right? So the slope of this line is 2. So, okay, I don't mean to ruin the surprise, but I hope that if I use this heavy machinery that I'm going to do here, I better get 2 as an answer, because I'm pretty sure this is just a regular old sort of diagonal line, which has a slope of 2. So I better get f prime, or the derivative of f, better be 2. But let's see. Let's just pretend I sort of didn't notice that and just proceeded to use this formula. All right, so I'm going to do the 4 steps involved in doing this from the last slide. So what is that I'm going to do? So first step is to fill the formula in, right? So here I've got f prime is f of x plus h minus f of x over h. So I need to fill in the numerator here. Okay, so I need to know what's f of x plus h, and I need to know what's f of x. Well, you know what f of x is. You already have that. It's right here. It's 2x plus 3. So that's pretty easy. So that's not going to be hard. That piece is requires no thinking. But for the first piece, you have to be just ever so slightly careful. So what is f of x plus h? And I'm going to probably sound silly saying it that way, but I'm going to try to emphasize to you that this is really saying x plus h is what you're plugging into the function. So if I asked you for f of 3, you'd hopefully all tell me, right? If I asked you what's f of 3, you'd hopefully say, well, let me look at the function. It's 2x plus 3. And you'd say, oh, I'm plugging 3 in for x. So I would plug a 3 in right there and get 9, I guess, right? That's what you get if you plug 3 in for x. Well, there's no difference between the little story I just told you and what I'm asking you to do right now. It's just that instead of 3 being what you're plugging in, I'm asking you to plug x plus h in. Well, if you want to plug in x plus h, you should plug x plus h in for x. Okay, so what's f of x plus h? Well, that should just be this. It should be f of x, but with x plus h plugged in for x. So that is f of x plus h, 2 times x plus h plus 3. Okay, so hopefully that makes sense. I don't know how else to exactly say that, but there it is. All right, so let me just redo my arrowing here So this piece is right there. Okay, then what else? Well, then I have to do minus. That's what the formula says up here, right? Minus f of x. Well, that's a no-brainer. F of x is right there. So minus 2x plus 3. Now, I'm just going to point out a rookie mistake that I'm sad to report comes up many, many times and is always going to create a wrong answer, unfortunately, which is that you just have to be a little bit careful here. When I'm saying I'm subtracting, right, which I am, subtracting f of x. What is that? Well, that's f of x, and that's f of x, and I'm subtracting it. But hopefully you maybe did something like this, and I should have, right? When I write that down, I'm subtracting that whole thing, not just 2x. So when I didn't put parentheses in there, you might think you're Captain Awesome and are going to remember later that you wanted to subtract the whole thing. But experience tells me that you're more often going to forget that you were supposed to subtract the whole thing and just do minus 2x plus 3, because that's what it looks like to me. So just do yourself a favor and don't be afraid of using parentheses to help remind you that you're subtracting that whole thing. Okay? All right, and then I have this h on the bottom. All right, so I've done the formula, which, sorry, looks awful right now, but that was the formula. That's step 1. Fill in what you know. There it is. That's what I know. So, all right, what am I supposed to do now? So step 2 is to say, all right, I want to simplify this and do some canceling, and I hope I can factor an h out. Well, I don't immediately see that I can do that just yet, but hopefully I'm not a big liar, and hopefully I can. So let's see. Simplifying is usually just sort of doing some algebra, multiplying stuff, combining stuff, subtracting stuff, whatever. So I don't know, right? I don't really have a lot to say except, well, I've got some terms here. I could multiply this out. I could distribute the 2, in which case I'd get 2x plus 2h plus 3. And then on this guy, right, again, I'm subtracting each of them. So I really would distribute the negative sign, and I'd say minus 2x minus 3. Remember, you have to distribute this to both. Okay, and that's all still over h. Okay, and what else can I do? Well, again, algebra, right? I kind of notice, I think, in the top of the fraction, I have 2x and negative 2x. Well, that's 0. And I have plus 3 and minus 3. That's also 0. So a lot of good things will happen when you do this. In fact, I'm left with what? Just 2h on top? That's it? And just h on the bottom? Well, that's pretty good. And so now I can say I guess this is still sort of under step 2. I factor an h out on the top. Well, it's already factored out, right? I already have just 2 times h. So step 3, right, is to say now I can cancel the h that I factored out on the top with the h that's on the bottom. And, you know, I didn't even really need to be that fancy about that. I could just say, well, you have an 2h over h. The h's cancel. And in fact, what I'm left with is 2. And I'll just write down. Remember, that was sort of being carried through the whole time. Now, step 4 is to plug in h equals 0. Well, don't freak out, right? If I want to plug in h equals 0 right now, what does it mean to say plug in h equals 0? It just means wherever you see an h, put a 0. Well, all right, I can sort of vacuously do that by saying, well, I did that, right? Whenever I saw an h, I put a 0. Well, I didn't have any h's, so it's just 2. And that's it. Now, my claim is that that's the derivative, and let's see if that makes sense. What did I say 10 minutes ago when we started this problem? Was, remember, this is really just y equals 2x plus 3, which is just a line. And the slope of that line, because that's m, is 2. And look at what we got for our answer. We got for our answer that at any x value, if you could plug in 7, you could plug in negative 9 million, whatever x value you plug in, it doesn't matter because the answer is always 2. But isn't that exactly what a line is, right? A line is something that has the same slope no matter where you are, no matter what x value or y value you're at, the slope is always 2. So in our first example of doing this, kind of with this definition of a derivative, I got an answer that agrees very much with the intuition of what we know or what we expected, which was that this should always have a slope of 2, and it does. Okay, so all right, so that's an example, and we had some sense of what the answer was going to be, so that was reasonable. All right, so let's try another one. So if I have f of x, let's try something for which the answer isn't going to be so easy. So I think I wrote this on a previous slide, so let's do this one, 3x squared. Now that's a parabola, so it's curvy, so it's not going to have an answer like the one we just had, right, which is just a constant number. It's going to change. The slope is going to change depending on where you are. So I don't expect to get just a number for this answer. I should probably have x's in it, but we'll see. All right, so I want to know what's the derivative, right? So it's the same question, compute the derivative or compute f prime of x. So all right, I'm going to do my formula, which is on the last slide here, which is what is f of x plus h minus f of x all over h. Okay, so I have to know what's f of x plus h. Well, again, what does that mean? That means that in my formula, if I want x plus h there, that means I should put an x plus h there. So f of x plus h should just be 3 x plus h squared. Okay, so I don't know what else to say. Unfortunately, I know a lot of people will write something other than that right there, and I'm not sure how to better convince you of to not do that. It's tempting, I guess, to write like 3x squared plus 3h squared or something like that, or I don't know. People write a kind of a variety of things for this, but I don't know what else to say. Again, if I was plugging a number in for x, if I was asking you for f of 2, I think you'd all hopefully say, okay, so x is really 2, so I put a 2 in for x, and I get 12 for my answer. Well, I'm asking you for f of x plus h. Right? That's what's in the formula. So I should say, all right, so x plus h is playing the role of x, so I should drop that in right there. And that's exactly what I did, right? That's f with x plus h filled in for x. Okay, so that's f of x plus h. Then I need to do minus f of x. Well, that's easy. F of x is just that. And remember, if you have more than one term, using parentheses here probably helps. But in this case, I only have one term, just 3x squared. So I think I'm good with just that. And then I'm dividing everything by h. All right, so that's just the formula. Again, this same old guy that we're now using repeatedly. All right, so step 1 done. I filled in everything I know. And now I want to do step 2, which is to simplify. And again, there aren't a whole lot of things I know how to do algebraically, but in this case, I kind of see a square there. I have x plus h squared, which hopefully jumps out at you as maybe something that I could FOIL or multiply it out or whatever, and maybe I can do some combining and et cetera, and magic will happen again. So I'm going to figure out what x plus h squared is. So feel free to, come off to the side if you need to in order to compute that. And, I'll do it slow for everybody. If you want x plus h squared, that's really x plus h times x plus h. So, and that's just foiling, right? So FOIL is something we should all know how to do already. So FOIL says take the first 2 terms, that's x squared. Take the outside terms, which is xh. The inside terms, which is also xh or hx, but same thing. And then take the last 2 terms, which is h with h. Okay, so if I FOIL, and I can combine these 2 guys in the middle here, I'm going to get that. Okay, so x plus h squared is really that. All right, so let me drop that in over here in my problem now. Let me say, okay, so that's really the same thing as that. So let me substitute that in there. So I'd have 3 times this, x squared, plus 2xh plus h squared. Okay, that's just what that was for my side work. And then I still have minus 3x squared, and I still have h on the bottom. Okay, and again, I have a 3 in front there, so that kind of is hopefully begging for this to just be distributed. So let me distribute the 3 to each of these guys in the inside. So I'd get 3x squared and 6xh and and 3h squared. Okay, so that's distributing the 3 to each of those guys in the parentheses. And then I still have this minus 3x squared that's been there the whole time. And I still have this h that's been there the whole time. All right, so finally I'm done with sort of expanding, I guess. And now I think I can hopefully see that I can do some canceling, right? I have 3x squared and negative 3x squared, and that should be, I can cancel that. So what I'm left with on the top is 6xh and 3h squared. Now my claim to you was that in each of these problems you should be able to factor an h out of the top after you do your simplifying. And I think you can see that, hopefully, that I only have 2 terms left on top, and they each have an h. So I can legally factor out an h from the top, and then I just need to ask, well, what's left? 6x and 3h. That's what's left. And I'm still dividing everybody by h. And now is where I can do what I think I was calling step 3, which is to cancel out the h in the top with the h in the bottoms. Now don't go crazy and also cross out this h, for example. Why should you not do that? Well, you've already factored an h out of the top. So the top really reads h times some stuff divided by h. So if I want to cancel out the h's, it's this h and this h, because this h was already multiplied to each of the things. So don't go crazy and just cross out every single h. That's not right. In fact, you'll get the wrong answer if you do that. So, but this h, right, can cancel with this h because it's everything is multiplied. All right, so if I do that, I'm just left with 6x plus 3h. So let me come over here. So I'm down to just 6x and 3h. Okay, so I'm ready for step 4, which was go ahead and now plug in h equals 0. Again, at every step of my process, I could not plug in h equals 0 because I had an h on the bottom, an h on the bottom, an h on the bottom. And for the first time, I don't have an h on the bottom anymore. So this is also the first time where you can now freely and legally plug in h equals 0. And again, the motivation there being that I'm assuming, or I'm trying to consider what's happening as my second point moves closest to my first point from our little method. So when I plug in h equals 0 right now, 6x, well, there's no h there, right? So when plugging in h equals 0, so to speak, doesn't do anything to 6x. That's just 6x. But 3h, if I say h is equal to 0, you'd hopefully all tell me that 3h is 0. If h is 0, then 3h is certainly 0. So what my last step here is to plug in h equals 0, which means that one, because that's the only h I see, which should make that piece 0. And so in the end, I'm ending up with just 6x. And my claim is that that is, in fact, the derivative of 3x squared. Now, you know, how do I know if that's right is sort of a good question. The last example we did, we picked a function, or I picked a function that was so simple, right? This was just a line. So we kind of knew what the slope was already, and yes, we confirmed that 2 is indeed the slope of that line. Well, I don't, off the top of my head, automatically know what the slope of this parabola is that we started with. So when I get 6x as my answer, well, you know, okay, I guess I'd like to believe that that's right. If you want to do a little bit of just sort of exploring, we can say something to try to make ourselves maybe have a little more confidence that this might be the right answer. So I'm just going to take a small, just 5 minutes to sort of say, well, what is that? So we got for f of x being 3x squared, we got that the derivative turned out to be 6x, right? That's what we just computed on the last slide. So what should that mean? That means that the slope of this function, right, that graph, at any x value that you want, the slope should be attained by simply plugging that x value in here, which of course means plugging it in here, and that should tell you what the slope is. So in other words, if I wanted to know what the slope was at x equals 2, I would plug 2 in for x here, which obviously means I plug 2 in here, and of course you'd get 12. So the question would be, is that right, I guess, right? So, well, if this is the function, you could graph it and at least have some sense of, is 12 reasonable for the slope at x equals 2? And, you could do this on a calculator if you want to graph it. I'll just sketch a graph here for you. If I wanted to say, what's the graph, right, of 3x squared. So 3x squared is a parabola, but it's a very tall parabola. It's a very steep parabola. So it probably looks something, kind of looks something like this. Okay. So let's see. Does this make sense? So let me be a little more formal here. Whoops. So just some sort of exploring. You don't really have to do this each time, but just some exploring here, right? So if I say, if I put an x and the derivative, this is an easy chart to fill in. I could fill in some x values and see if they agree with my graph over here on the left. So let's pick an easy x value first, maybe 0. Well, at x equals 0, the claim, since I could plug 0 into 6x, right? So the derivative here is 6x. That's what we computed. Well, if I plug in x equals 0, you get 0. Well, that means that the graph should have the graph of f of x should have a slope. Remember, the connection between f and f prime, or the connection between f and the derivative of f, is that the values of the derivative are the slopes of f of x. Okay? So let me come over here. This is a graph of f of x, right? That's what I just sketched for you. That's 3x squared. So is it true that at x equals 0, you have a slope of 0? Well, that's x equals 0. And what does the slope of this graph look like? I don't know. It looks pretty flat to me. And flat is 0. Slope is 0 if I say something is flat. It has a slope of 0. So far so good. But let's try some other things. So let's try maybe x equals 1. All right, at x equals 1, if I filled 1 into the derivative, I'd end up with 6, right? 6x. If I plug in 1, I get 6. So again, this should say, so the slope at x equals 1, right, should be 6. Well, 6 is sort of, it's uphill, it's positive, and it's a reasonably large number. So it would be saying for every 1 step to the right, you take 6 steps up. Well, x equals 1 is probably somewhere around here. So if I look at the graph at x equals 1, the slope of the graph would be sort of like that, I guess. And is it reasonable that that might be a slope of 6? Sure. 6 is, pretty steep, and it's positive. So it's believable that that has a slope of 6. So, all right, that's okay. Maybe I'll just do one more here. How about negative 1? Well, at negative 1, if I fill that into my derivative, I'd get negative 6. So again, the idea would be that the slope at x equals negative 1 should be negative 6. Well, negative 1 is somewhere around there, I guess. So if I go up to the graph, that's the slope of the graph right there. And is it believable that that's negative 6? Well, I mean, it's hard to say precisely. But negative makes sense because it's going downhill, so that's good. And it kind of looks similar to the 6 that I just drew on the other side, except just going in the opposite direction. It's pretty steep. So, it's pretty reasonable, I think. You could do a little more exploring if you really want to, and, plug in some other values. But I think I buy this. I think that this is the correct answer. And, well, I can certify it to you that it is the right answer. But it shouldn't be, there should be at least some idea of why, or at least some confirmation, I suppose, that this makes sense. And I think it does, right? I think that the 6x makes sense to be the derivative of a parabola by these 2 points or 3 points we picked, and then others. Again, you can do more of this if you want to further convince yourself. But anyway, there you have it. So, right, so if I want to know the slope at any point now, what's wonderful about having a derivative, or sort of a formula for the derivative, if I want to know what's the slope of the graph at x equals 10. Well, that's just saying what's the derivative at x equals 10. Oh, well, the derivative formula is 6x. So if you want to know what's happening at 10, just plug 10 in, and you get 60. So 60 meaning for every 1 unit of change in x, your y changes by 60. Well, that's extremely steep. That's like a mountain that has almost, that almost goes straight up. It's like a cliff more than a mountain. Okay, but that's what this graph would look like at x equals 10. By the time I'm out here, I mean, this is super not to scale, but by the time I'm way out here to 10, I mean, the graph is way off the top of my screen here, right? But it's very steep. I mean, it is increasing rapidly. So it should be almost vertical, which that's what a slope of 60 would mean, that you have lots of rise and very little run. So you're going pretty much straight up. So anyway, all right, so we could go on and on and on and analyze this more, but this is good enough, I think, for us to hopefully be convinced. And if I swear to you that it's the right answer, you'll hopefully believe me. Okay, so maybe just one more example of what you might do. So I thought I would just do one more. This is, I think, number 3. Let me do one more polynomial, just an easy guy in terms of it just being a basic function. How about x cubed? Okay, so this is just, so we did x squared, right? That was the thing we did on the worksheet, was x squared. And as it turned out, the derivative of x squared turned out to be 2x, if you remember. So let's try x cubed. That's sort of 1 degree harder than x squared. And let's see what we get. Okay, so again, the question is, what's the derivative, or compute the derivative? So I'm going to use my formula and do my 4 steps. So step 1 is to fill in what is the numerator of this guy. So remember, the formula says it's f of x plus h minus f of x over h. So f of x plus h should just be x plus h cubed. Okay, because again, right, if I'm trying to say what is f of x plus h, that's saying plug x plus h in for x. Well, that's just what I did. I guess I should say, why is this not, I guess, hold on, I don't know, I'm trying to be you guys and think about what might you be hung up on. I mean, I suppose some of you might say that in the sense that if you're looking to figure out what's f of x plus h, I guess it's tempting to kind of do something like, well, if f of x is x cubed, then f of x plus h should be like x cubed and h cubed, I guess, or something like that. I mean, that's wrong. So I don't know how, again, not sure how else to say it except to say to you that, again, think about what does function notation just mean in general, is that whatever I put here is playing the role of x. So, which means in my formula, I should also put it there. So if I wanted to know what f of 3 was, I'd plug 3 in for x, and I'd get 27. If I want to know what f of, I don't know, anything else, any other function, you could plug in anything you want there. You could plug in e to the x, and then you just get e to the x cubed. So it's just a question of saying whatever I put here also goes here. So in the definition of the derivative, I'm supposed to do this, right? That's the definition of the derivative. So, well, all right, the first thing it wants me to do is put x plus h in for x. So I'm going to do that. I'm going to say, all right, I'll plug in x plus h, which means that's what I'd get. Okay, so, and then I have minus f of x. Well, that's easy. F of x is just x cubed. And I'm dividing everybody by h. Okay, so so that's my fill-in step, and now my next step is to do some algebra. And this is now the third one or fourth one we're doing, so hopefully you're kind of catching on that you basically end up just sort of doing multiplying stuff out and combining and doing some simplifying. That's pretty much how these will all go. So I'm going to do that for this one as well. So what is it that I have to multiply out? Now I have to do x plus h cubed. Okay. Which I'm going to just spare us a little bit of time and say x plus h cubed. Well, there's a shorthand way to do this, and maybe some of you know it, but I'll just say, what is that? Well, it's x plus h times x plus h times x plus h, right? But in particular, that's x plus h times x plus h squared. Well, we did x plus h squared in one of the previous problems, and if you recall, I think that's what we got. That was x plus h squared. So in order to do x plus h cubed, I would just need to do this, which just consists of you distributing each x and h has to be distributed to each of these terms, and you add them all up. So you'd end up with 6 terms, which I really don't want to write out for you, and you'd combine like terms, okay? But I promise if you did all that, let me spare us the 10 minutes of me doing it, you'd end up with the following. So if you cube this, you'd end up with x cubed, and you'd get 3x squared h, and you'd get 3x h squared, and you get h cubed. Okay, so do it out the long way over here. You know, you do that stuff, and I promise you'll get that, what I just wrote down. Okay? All right, and then the other thing I still have up here is this minus x cubed, right? That's still up there, so don't forget that. And then I'm dividing everybody by h. Don't forget that either. All right, and as usual, I get a good thing that happens, which is that I can cancel. I have plus x cubed and negative x cubed. That's 0, which just leaves me with that stuff in the middle. And again, just like as promised, you can factor an h out of each of those 3 terms that's left in the top, because they each have at least one h to give. And so if I factor, I'd end up with h, and then what's left? 3x squared, 3xh, and h squared, I think. And I'm still dividing everybody by h. Okay, and so that's sort of the end of step 2. Step 3 says, well, look, now you've got h times some stuff all divided by h. Well, that's silly. Don't multiply by h and then divide by h. That's just the same thing as doing a fancy 1. So that's really just 1. All right, h over h is just 1. So all I really have is just this stuff in parentheses. So I'm left with just 3x squared and 3xh and h squared. Okay, so that's sort of the end of step 3. Now step 4 says, in our strategy for making the magic happen, is that at the end, what I really want to say is h, for the first time now, I can actually plug in h equals 0. I couldn't do it anywhere above because I was dividing by h. But now I'm not dividing by h. It's just, you know, everything is on the top, so to speak. So now I can actually plug in h equals 0, which sort of completes the method, right, the strategy. And if I do that, well, what's going to happen? Well, that's going to turn into 0, because if h is 0, h squared is certainly 0. And even this piece here, that's also 0, because again, I don't care what 3x is. If you multiply by 0, you're going to get 0. 0 kills everything. Okay, so far I don't have much. Now 3x, 3x squared, there's no h's in that. So when I quote-unquote plug in h equals 0, well, that doesn't do anything, because there's no h's there. So it's just 3x squared. So I think that's the answer. Right? I don't need these plus zeros, do I? Right? Those are just, like, you can just leave them off. So I think my answer is, to summarize then, for f of x equals x cubed, we computed the derivative, turns out to be 3x squared. Okay, so again, you can do the same thing I did at the end of the last problem, which is to, kind of draw yourself a little picture. You could draw a picture of x cubed, and then sort of analyze the slopes if you want. But I'll spare you that. But feel free to do that if you want. But that is the right answer. Okay. So, all right. So where are we then, right? So what should you be able to do? Well, hopefully you can do this method, because I will require that you be able to do this. For some basic problems. Obviously, if I give you something that's god-awful, then step 2 becomes, which is this step and this step, become just unbearable. So obviously, this is going to be awful to do unless the functions are, kind of relatively basic. So, but I do think you should be able to do this for basic functions, polynomials primarily. So, now, I'll just leave us with this comment, though, which is that this is nice in the sense that this tells us about the derivative. It's nice because at the end, I get a formula for f of x, for the derivative, right? If I wanted to know what the slope was at x equals 1, I could just plug in 1, and I'd get 3. And I'd say, oh, the slope of the graph of f of x is 3 at x equals 1. And so on and so on. You plug in any x value you want, magically this gives you the slope. So that's nice. But where we're still should be a little unhappy with our lives is that this is kind of a pain in the ass, though. I mean, this is I don't know how long this one took me, 10 minutes maybe? I mean, that's not great. And of course, as always, as human beings, we'd like to maybe always see, is there a faster way to do something or a faster way to do this? And I won't ruin the complete surprise, but the answer is yes. And in fact, if you've taken any calculus, you probably have known what the answers to these questions were within like 5 seconds. So, and that's totally reasonable to say, if there's a shorter way to do this, we should learn that, because, dear God, this is kind of awful. So, what we will do in the next videos will be to learn some shortcuts, and by that I really mean some very, very, very fast shortcuts for how to do derivatives without really having to use this monstrosity every time. And that's practically, of course, how you will do derivatives for the rest of the semester, is the short way. But I will insist that you do, at least one this way on the first exam and probably on the final exam too, just because this is the beautiful part. The rest of it's just sort of, you're a robot and you're going to do derivatives, and that's fine. But this is where it all comes from. So, so we do have to be able to do it this way. But yes, in practice, there is a much faster way. So, but that's what will be in the next video. So, all right, as always, send me any questions if you have any about anything, and I can try to explain it to you, in an email or whatever. And check out there's practice problems for these types of questions where I will, basically ask you to kind of do some of these a long way, and maybe ask you to kind of short answer some essays about, or short answer questions about steps. Why did we do this and that? So check those out below the video, and good luck.